here is a dual shaft mixer which has one anchor and a high speed disperser. Now the purpose of the slow moving anchor is to direct the material to the high speed disperser, and the high speed disperser is where the shear takes place. It's a high shear zone and the mixing takes place there. So just like you have the dual shaft mixer which has two impellers, you have the triple shaft mixers where you have not two but three impellers. So with the triple shaft mixer it is possible to increase the viscosity up to 750,000 centipoise. Moving on, when it is not possible, to have a flowability of the material by the action of the impeller or by the rotation of the impeller, how do you mix then? So the next option is you move the mixing agitator throughout the vessel, and that's what we do in the planetary dispersers. So in the planetary dispersers you cause a planetary motion of the mixing impellers. You have the rectangular planetary braid and you have the high speed disperser, and they just don't rotate around their own axis, but they revolve around the axis of the bowl. So you are in a position to reach all parts of the mixing vessel, and that's an indication of how the rotation or the planetary motion takes place. And these mixers can be used at viscosities up to 1 million centipoise. Now as you go over 1 million centipoise, what do you do next? You have the double planetary mixers. In double planetary mixers you don't have just one, but you have two mixing impellers or two beaters, both of which rotate around their own axis as well as revolve around the bowl. Now within a minute or within less than a minute, in 36 revolutions, what you see is that the mixer, the rotation of the mixers has covered the entire mixing vessel. The video there shows the operation of a double planetary mixer, the movement of a double planetary mixer, and we would actually see how a compound high viscosity about 5 to 6 million CPS has been mixed in that. So we are in a position to go up to viscosities of 3 million. That's what the literature stated, but with improved designs you can easily go up to 6 million centipoise. Also, it could be a jacketed vessel. You could provide scrapers, so you are in a position to make sure that you remove the material from the vessel walls. That's after the mixing. You get a feel of the material viscosity. These are typically change can mixers, and I will touch upon the change can mixers as we move forward. Moving up, when the viscosities increase, and this is one of the most recent developments, and this is what high viscosity is, the future of high viscosity mixing, is an improvised version of the double planetary. The rectangular beaters are now replaced by the helical beaters. So with the helical beaters, you are in a position to handle higher viscosity materials. Most importantly, materials which are light and tend to kind of ball up and come to the agitator surface. Because of the profile of the mixing impeller, they are pushed down. You have the high speed dispersers along with the beaters, and that adds to the shear. So with these kind of mixers, you can easily go up to 8 million centipoise.